Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled A Solar Eruption from SDO. So what do we see here? Well, here we see a very short clip showing a coronal mass ejection being ripped off from the sun. Now it's a short video clip only running a couple of seconds, so I'm going to put it on repeat as we discuss and take a look at it. Now this is an image of the sun taken by the Solar Dynamics Observatory, and specifically what is known as its atmospheric imaging assembly. And that takes images at various different wavelengths, and here we put them together to get a single video clip that we see. And in fact, the different colors are really associated with different wavelengths in the ultraviolet and what we call the extreme ultraviolet. Now that just means it's the part of the ultraviolet farther away from the visible spectrum and getting closer to the X-rays. So it's very intense ultraviolet energy. Now, the colors that we see include red, which is the cooler material down in the lower atmosphere of the sun. The yellow shows hotter material in the coronal loops of material. And then finally, we'll also see a little bit of blue down near the source where this erupts. That is really the very most intensely heated area that we see. Now, a coronal mass ejection like this is similar to a solar flare on a much larger scale, which is also similar to a solar prominence. Now, in a prominence, we just see a little bit of material being lifted off the sun and then rains back down on the sun in a 1,000-degree plasma. In a flare or coronal mass ejection, the material is lifted off and is actually ripped off the surface of the sun. Same process, but happens with much more energy and removes the material from the sun altogether. And you can see that in this video clip as the material is flung out from the sun. It's the magnetic field that is doing this. You can see some of the effects of the magnetic field in the image in terms of the regions around it where there are various different loops of material. Those are also part of the solar magnetic field. The material of the sun then follows along those magnetic field lines, highlighting them. Otherwise, magnetic field lines would be quite invisible to us. But sometimes they lift the material up very gently. We get a solar prominence where you just might see a loop of material along the limb of the sun. In other cases like this, they rip the material off the sun as the magnetic field breaks through the surface, carrying that plasma and ripping it off into space. Now, when that happens to come in the direction of Earth, that's when we get solar storms. Often those are associated with the aurora. Those same charged particles being lifted off the sun here could come near Earth and give us auroral activity, where we see the glowing of the sky from those solar particles. A very intense coronal mass ejection is much more energetic and actually can cause significant damage here on Earth. A strong coronal mass ejection directed at Earth could fry various electronics either in orbit or even on Earth itself. Now, we haven't had a major coronal mass ejection pointed directly at Earth. They occur all the time, but for one to hit Earth, it is, a 1 in every couple 100-year type event. The last one was back in the 1850s, so long before we had a lot of electronics. Now, something like this happening now could cause significant damage depending on exactly how it hits Earth and how intense the material strikes our planet. So that was our picture of the day, titled A Solar Eruption from SDO. We'll be back again tomorrow for the next picture, previewed to be Pool of Whirl. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.